Hello everyone, welcome to MEMONEET. How are you all? I hope everyone is doing good and I hope the preparation is going well. So on Sunday you are having your next BPT. So for that the chapter that is coming is coordination compounds. So from the last two lectures we have been studying coordination compounds. So I hope आप लोगों ने last two lectures देख लिए हैं and all the topics are clear. So in case you are facing any issues or any doubts, you can comment below or you can contact us through the Telegram channel. Okay. So please ask us your doubts. I know during the preparation many doubts will come, right? Especially in physical chemistry and ऑर्गेनिक तो हम बाद में करेंगे राइट बट इन फिजिकल केमिस्ट्री जो भी चैप्टर्स अभी तक हमने पढ़ लिए नॉट जस्ट द ऑनगोइंग चैप्टर the chapters that we have covered already, so you can ask your doubts from that as well and we are here to help you out. Okay, so coming back to coordination compounds, in the last lecture we talked about the isomerism, ki what kind of isomers are seen in coordination compounds with examples, and in detail we studied that yesterday. So today, as I have promised you, so today what we are going to study, we will be learning about the valence bond theory. Just a minute. Yeah. So we will be learning the valence bond theory. So basically we have to see the bonding in coordination compounds and we need to know a lot more about it, ki what kind of structure they are having, what kind of geometries they are having, then about their magnetic nature, about the bonding and all of that. So that we will be studying using, there were many theories, valence bond theory, molecular orbital theory, crystal field. So in our syllabus we are having valence bond theory and crystal field theory. So today we are going to cover the valence bond theory with examples we will discuss. Okay, so keep your notebooks and pens ready so that we can start now. Okay, so if I am talking about the valence bond theory, according to this theory, the metal atom or ion under the influence of ligands can use its n-1d, ns, np or np, nd orbitals for the hybridization. So what happens is when ligand approaches the metal atom, these orbitals, okay, n-1d orbital, ns, np, n plus 1s and plus 1d orbitals, they actually undergo hybridization. Hybridization we have already studied in the chapter chemical bonding, right? So they get hybridized to yield a set of equivalent orbitals of definite geometry. So in that case we know कि if there is a particular type of hybridization, there would be a particular geometry. So if we know the hybridization of our coordination compound, so in that case we can know their geometry as well, right? कि how the hybrid orbitals are distributed in space. So वहां से geometry से हमें पता चल जाएगा what the structure of your coordination compounds. Okay, so ये जो hybrid orbitals बनते हैं, when these hybrid orbitals are formed, now these hybrid orbitals are the ones that will overlap with the ligand orbitals, और वो जो ligands हैं they will donate electron pair for the bonding. So we know कि the metal atom acts as the Lewis acid. Here the ligands are the ones that are Lewis bases, means they are donating the electron pair. ओके सो यहाँ पर इस टेबल में वेरियस हाइब्रिडाइजेशन जो पॉसिबल है कोऑर्डिनेशन कंपाउंड्स में दैट कैन बी सीन. सो यू नो फॉर कोऑर्डिनेशन नंबर 4 देयर कैन बी टू टाइप ऑफ हाइब्रिडाइजेशन, sp3 और dsp2. तो अब sp3 तो वी ऑल नो कि whenever sp3 hybridization is there the compound shape is tetrahedral. dsp2, so dsp2 में inner d orbital involved होता है. ओके So inner d orbital is involved in this case and the shape would be square planar. Then we have coordination number 5. So उसमें 5 orbitals होंगे sp3d. sp3d is trigonal bipyramidal. Okay. अब ऑक्टाहेड्रल में भी क्या रहता है, कोऑर्डिनेशन नंबर 6 की अगर हम बात करें तो दो तरह के कंपाउंड्स बन सकते हैं. ईदर आउटर डी ऑर्बिटल्स आर इन्वॉल्व्ड और इनर डी ऑर्बिटल्स आर इन्वॉल्व्ड. तो शेप दोनों में ऑक्टाहेड्रल रहेगी. इट्स जस्ट दैट कि इफ sp3d2 है होगा सो वी विल बी कॉलिंग इट एज आउटर ऑर्बिटल, वो भी हम पढ़ेंगे आउटर ऑर्बिटल कॉम्प्लेक्स. बट इनर डी ऑर्बिटल्स भी इन्वॉल्व हो सकते हैं. कैसे इन्वॉल्व होंगे इनर डी ऑर्बिटल्स इन द हाइब्रिडाइजेशन, दैट वी विल सी. बट जस्ट रिमेंबर कि इन बोथ द केसेस द शेप इज गोइंग टू बी ऑक्टाहेड्रल. ओके, सो वहां पर मैग्नेटिक बिहेवियर चेंज हो जाएगा बट द शेप विल बी ऑक्टाहेड्रल. ओके, सो कुछ assumptions हैं और कुछ points हैं that you have to remember. So according to the valence bond theory, central metal ion has a number of empty orbitals that can accept electrons. Okay, तो वो empty orbitals होंगे तभी electrons accept कर पाएगा. And the thing is कि the coordination number of that metal ion will be equal to the number of empty d orbitals. Okay, तो जो empty d orbitals का number होगा, that will be the coordination number of that metal ion. Okay, next, strong bonds are formed when the metal orbitals and ligand orbitals overlap. Of course, जब metal orbital और ligand orbital overlap करेंगे, strong bonds will be formed. And जितना ज़्यादा extent of overlapping रहेगा उतना ही stable आपका complex होगा. Okay, and different orbitals SPD we have just discussed, they hybridize to form a set of hybridized orbital that participate in bonding. Okay, and each ligand contributes 2 electrons to the central metal atom. All right, so here we have seen that each ligand will contribute 2 electrons to the central metal atom or ion, and the inner orbitals contain non-bonding metal electrons and that will not participate in the bonding. And if we can talk about the magnetic nature of the compound also, a compound is paramagnetic if it contains unpaired electrons, and we will be saying that the compound is diamagnetic if it does not contain any unpaired electron, means if all the electrons are paired. And under the influence of strong ligand like Cn and Co, electrons can be forced to pair up, thereby violating Hund's rules of multiplicity. We will see कि कैसे pairing होती है. All right, so we will be discussing about inner orbital and outer orbital complexes. So what happens is when outer d orbitals are used in bonding, we call it as outer orbital complex. जैसे हमने देखा in octahedral, if sp3d2 is there, okay, so we will be calling it as an outer orbital complex. Like we will be discussing this also. We will be having CONH36 and COF6. Okay, so basically your outer orbital complex is COF6 3 negative, and here अगर D2sp3 है, that will be the inner orbital. So यहाँ पर n-1 d orbital will be used. We will be calling it as inner orbital complex. So CONH36 3 plus, so that will be your inner orbital complex. So this is the outer orbital complex, inner. So d orbitals की participation के ऊपर ये depend करता है. Now one more thing you need to understand, there are two types of ligands, strong field and weak field ligands, that we will be discussing in detail in crystal field theory, but try to understand कि outer orbital complex will be formed due to weak field ligands, because weak field ligands cannot डू द पेयरिंग ऑफ इलेक्ट्रॉन्स. तो वहां पर पेयरिंग ऑफ इलेक्ट्रॉन्स नहीं करवा पाते वो, इस वजह से आउटर डी ऑर्बिटल इन्वॉल्व होते हैं बॉन्डिंग में, एंड तो वहां पर अनपेयर्ड इलेक्ट्रॉन्स होने की पॉसिबिलिटी भी ज्यादा रहती है. सो वीक फील्ड लिगेंड्स ऑन we will be calling them as high spin ligands also, because जो complex बनेगा वो high spin complex बनेगा, means it will be having more magnetic nature. Okay, ज़्यादा magnetic moment उसका होगा, it will be having more number of unpaired electrons. Then whereas strong field ligands are the ones that cause the bonding. ओके, अब वो क्या करेंगे, दे विल कॉज पेयरिंग ऑफ द इलेक्ट्रॉन्स, एंड पेयरिंग हो जाएगी, उस वजह से यू विल बी गेटिंग लो स्पिन कॉम्प्लेक्सेस. ओके, पेयरिंग होने की वजह से यू विल बी गेटिंग लो स्पिन कॉम्प्लेक्सेस. ओके, सो दैट इज द थिंग. So now we will see now how these compounds are formed, or these complexes are formed. So for that, let us try to understand for the octahedral compounds. Okay, first of all we will see some octahedral examples. Okay, means 6 ligands which are unidentate. So we have CONH36 3 positive. So the very first thing that you have to do here, students, is find the oxidation state of the metal. So here you know I hope you know how to find it out. So cobalt के लिए X ले लो, and ammonia is a neutral ligand. It does not have any charge. So 6 into 0, and overall charge will be equal to the charge on the complex. So it is plus 3. So it means from here the value of X is plus 3. So here cobalt is in plus 3 oxidation state. Okay. Now you have to write the electronic configuration of CO3 plus. Alright, so for that you need to know the electronic configuration of transition elements. So you have not studied abhi tak, we have not studied D block elements, but I'll write here for atomic number 21 to 30. Actually we have these transition elements जो कि आपके compounds में आएंगे. So if you want to write the configuration, you can write from here. Okay. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So यहाँ basically क्या होता है? The 3D start to fill up. All right. So 3D1 4s2. 4s2 is already filled. Now we have this 3D1. Okay. So it is 3D2 4s2. Then 3D3 4s2. अब यहाँ पर होना तो चाहिए 3D4 4s2, राइट, बट इट इज नॉट 3D4 4s2 बिकॉज यहाँ पर हाफ फिल्ड हो जाता है. ओके, हाफ फिल्ड. सो because of that it is not 3D4 4s2, ये नहीं होता है. It is 3D5 4s1 because 3D5 is half filled D subshell and it is more stable. Okay, so then again 3D5 4s2, then 3D6 4s2, then we have 3D7 4s2, 3D8 4s2, 3D9 again. अब यहाँ पर 3D9 4s2 होना चाहिए था, but again 3D10 will be fully filled, it will be more stable, so it is 3D10 4s1 and 3D10 4s2 fully filled. So 29 atomic number copper and chromium have anomalous electronic configuration, otherwise बाकी सब same है. Okay, so now I have to write for cobalt. So this is cobalt. Cobalt is 3D7 4s2. Okay, 3D7 4s2. अब cobalt 3 plus means 3 electrons are removed. So 3 electrons remove हुए मतलब 3D6. ये दो S से निकलेंगे. इलेक्ट्रॉन्स फिल बाद में होते हैं D के, बट निकलते पहले S से हैं. ओके, ट्राई टू रिमेंबर. सो कोबाल्ट 3 प्लस इज 3D6. ओके, अब ये 3D6 है यहाँ पर, एंड वी आर हैविंग अमोनिया विच इज अ स्ट्रॉन्ग फील्ड लिगेंड. अब यहाँ पर पॉसिबिलिटी है कि ये इलेक्ट्रॉन्स पेयर हो जाए. हमने पढ़ा ना VBT के लास्ट पॉइंट में कि इन सम केसेस ऑफ स्ट्रॉन्ग फील्ड लिगेंड्स पेयरिंग हैपेंस विच वायलेट्स हुंड्स रूल ऑफ मल्टीप्लिसिटी. तो यहाँ पर पेयरिंग हो जाएगी. कैन यू सी, पेयरिंग इज हैपनिंग बट हुंड्स रूल इज बीइंग violated, but that is not happening generally, that is happening in the presence of the ligand. Ammonia ligand is causing the pairing of electrons. अब देखो हमारे पास inner d orbitals दो खाली हो गए. So these two will participate in the bonding. 4s and 4p will participate. So the hybridization will be D2sp3, and each ammonia ligand will give you 2 electron pairs, means 2 electrons. So it will give you 2 electrons, and this is how the bonding will happen. 2 electrons will come from the 6 ammonia, and here D2sp3 hybridization means it is an inner orbital complex. अब अगर हम बात करें magnetic behavior की, so you can see in this complex all electrons are paired. Okay, all the electrons are paired, so that is why it will be diamagnetic in nature. Okay, so it will be diamagnetic in nature. So it's a low spin complex. इसको हम low spin complex भी बोलेंगे. Okay. So strong field ligands usually form low spin complexes. Now same case for cobalt 3 plus का ही case देखेंगे, but now the ligand is different. The ligand is fluorine. Okay, so now it's COF6 3 minus. अब अगर आपको यहाँ पे इसका oxidation state निकालना है same X cobalt के लिए, now fluorine has -1 charge. Okay, so 6 into -1 and overall charge is -3. So X minus 6 is -3 and X will be -3 plus 6, so X is +3. So यहाँ से देखो, this is how you have to find out the oxidation state. So again cobalt is in 3 plus state, means it is 3D6. Okay, अब 3D6 है यहाँ पर, then 4s, 4p and 4d. Now this is the fluoride ligand, so fluoride will not cause pairing of the electrons. तो ये जो electrons है ये as it is पड़े रहेंगे. This inner d orbital will not participate in the bonding. So the 4s, 4p and 4d will participate, and the hybridization will be sp3d2. So outer d orbitals are participating in the bonding. अब देखो तो यहाँ पर वही क्या होगा, 6 pair of electrons will come from the fluoride ligand से आ जाएंगे. So an outer orbital complex is now formed. Okay. So this weak field ligand fluoride is forming an outer orbital complex, and if I talk about the magnetic nature, now you can see there are 4 unpaired electrons because these are not paired up, right? So 4 unpaired electrons you will find here in this complex. So it means this complex is paramagnetic in nature. Okay, so this is how we can find out the geometry. Also geometry दोनों केस में octahedral ही है, but the inner d orbitals and outer d orbitals का difference है, and the difference is of the magnetic nature. So structure, magnetic nature we can all find out with the help of the valence bond theory. Okay. So now let's see for the tetrahedral entity, means for 4 ligands. So 4 ligands may, you know, if the coordination number is 4, so 2 shapes can be there, that is tetrahedral or square planar. Okay, so basically यहाँ पर भी 2 types के complexes बनते हैं, inner orbital and outer orbital complex. So inner orbital complex are formed by strong field ligands or low spin ligands, and outer orbital complexes are formed by weak field ligands. Okay. Hybridization inner orbital. अब inner orbital मतलब dsp2, right? Inner d orbital will be involved. Okay, so 1 3d, 1 4s and 2 4p will be involved. So they will be having a square planar shape in inner orbital. Outer orbital में हाँ d orbital तो involved नहीं है. The hybridization is sp3, but we will be calling it as outer orbital complex because inner d orbitals यहाँ पर involved नहीं होंगे. खाली 4s and 4p will be involved, and it will be having a tetrahedral shape. So shapes के ऊपर क्वेश्चन आ जाता है. लाइक हमारे पास 2 कंपाउंड्स है NiCN4 2 minus and NiCl4 2 minus. So one is square planar and one is tetrahedral. So ये आपको shapes याद रखनी है. क्यों है वो भी अभी हम discuss कर रहे हैं, right? Because of different ligands. In both the cases nickel is in +2 oxidation state. Again, if I want to find the oxidation state, 4 into -1, because cyanide has -1 charge, so it's -2. X minus 4 is -2, so X is -2 plus 4, which is +2. So nickel is in +2 state. अभी हमने देखा था निकल की कॉन्फ़िगरेशन क्या होती है, 3d8 4s2. Okay, 3d8 4s2. So nickel 2 plus क्या होगा, it will be 3d8. Okay, 3d8. Now there is a possibility of pairing again. So cyanide is a strong field ligand, cyanoligand Cn. So pairing हो जाएगी इन दो electrons की, pairing will happen. And now in one d orbital is empty, so dsp2 hybridization will happen. Okay, and 4 electron pair आ जाएंगे आपके 4 cyanide से. Again you will see here कि no unpaired electron are present, so it's a diamagnetic compound. Okay, next if I see here, if I talk about COCl4, okay, COCl4 minus. Again यहाँ पर if I want to find out the oxidation state of cobalt, so X plus 4 into -1 is -1, so X is -1 plus 4, so again it's +3, and cobalt +3 just now we have seen it's 3d6, so 3d6 है. Okay, अब यहाँ पर chloride है, but chlorine is a weak field ligand, so pairing will not happen, and here sp3 hybridization will happen. 4 electron pair will come from the chloride. Okay, so again यहाँ पर unpaired electrons है, it would be paramagnetic in nature. Okay, and the shape also would be tetrahedral. And same will go for NiCl4. So NiCN4 was square planar. Here it will be tetrahedral. Why? Because chlorine, again here it is nickel 2 plus 3d8. So 3d8 है, but because of chlorine no pairing will happen, and sp3 hybridization will happen, and 4 electron pair will come from chlorine. But again 2 unpaired electrons will be present. Okay, 2 unpaired electrons. So it will be paramagnetic. Okay, it will be paramagnetic. So from this, from the bonding, from the hybridization, we'll get to know about the number of unpaired electrons also, and we will get to know about the geometry as well. So NiCl4 will have a tetrahedral geometry. Okay students, I hope this is clear. So this is how valence bond theory helps we can write the structures. But there are certain limitations. We know that to a larger extent it explains the formation, structures, magnetic behavior of coordination compounds. But there are a lot of assumptions that are involved. It does not give any quantitative interpretation of magnetic data. We will not get to know about the magnetic moment and all of that. It does not explain color. So this is important कि coordination compounds are mostly colored, okay, mostly. But it does not explain anything about the color, why they are colored. It does not give any quantitative interpretation of thermodynamic or kinetic stabilities. This is important कि this theory does not tells us whether the compound will be stable thermodynamically or kinetically. We don't get to know about the stabilities from here. It does not make exact predictions regarding tetrahedral and square planar structures. कि exactly predict वो नहीं कर पाता of certain compounds for 4 coordinate complexes. It does not distinguish between weak and strong. So ये तो हमने अभी मैंने आपको बताया कि chlorine is weak field and ammonia is a strong field. But how? That we have got to know from crystal field theory. यहाँ पर कोई बात नहीं हो रही है of weak and strong. बिकॉज यहाँ पर वो ये नहीं कह रहा है कि क्लोरीन प्रेजेंट है इसलिए पेयरिंग नहीं हो रही है. अमोनिया के केस में, साइनाइड के केस में पेयरिंग हो रही है. सो इट इज बेस्ड ऑन अजम्पशंस कि यहाँ पर पेयरिंग हो जाएगी, यहाँ पर पेयरिंग नहीं होगी. बट क्यों, वाई? दैट इज बिकॉज ऑफ लिगेंड्स एंड द इफेक्ट ऑफ लिगेंड्स विल बी स्टडिंग इन द क्रिस्टल फील्ड थ्योरी. सो दैट comes under the limitation of the valence bond theory. But this is important because valence bond theory के questions भी आते हैं regarding the shapes of the molecule and the hybridization. So you जो हमने examples discuss करे, I have taken all the examples from NCERT. Okay, so try to see other shapes also ki how the coordination compounds are formed and how this hybridization takes place. Okay, so we will be meeting in the next lecture where we will be discussing the crystal field theory. Okay students, so till then complete all these video lectures of coordination compounds, and if you are having any doubts please do comment there. Okay, so thank you so much, take care.